Colloids. Based on the size of particle, mixtures are classified into three. The first one is true solution, and the second one is suspension, and there is an intermediate state between true solution and suspension, and it is called colloid. So if you talk about the size of true solution, colloid and suspension, the size of particles in true solution is always less than 1 nanometer. While in the case of suspension, it is greater than 100 nanometer. The size of particles in the case of colloid is between 1 nanometer and 100 nanometer. It is greater than 1 nanometer and less than 100 nanometer. If we differentiate the properties of these three, you can say true solutions are homogeneous substances. Homogeneous means the properties of the substance is uniform throughout. While suspensions are heterogeneous. In the case of colloids, it is looking like homogeneous, but actually it is heterogeneous. It appears as homogeneous, but it is heterogeneous in nature. So, if we mention one example for each, you can say KCl in water is an example of true solution. So many other examples are there, but I am mentioning only one for each type. Then coming to suspension, AgCl, silver chloride in water, is an example of suspension. Colloids, so many examples are there. Starch, blood, milk, etc. are examples of colloids. Since the particle size of true solution is very less, it cannot scatter light. So the path of the light is not visible. Coming to suspension, particle size is very large. Since the size is very large, it scatters light. That is why we can see the particle by the naked eye. So coming to colloids, we can't see the individual particles by our naked eye, but some certain cases we can see the particles that we discussed later. So scattering is possible. Scattering is happening in colloid. Since the particle size is very less in the case of true solution, we cannot separate the individual particles by simple methods. Cannot separate it by using simple methods. But in the case of suspension, particle size is very large, so simple methods can use. Simple methods works. Coming to colloids, some physical and chemical methods are used to separate the particles. Simple methods cannot be used for the separation, but some physical methods like centrifugation is used for the separation of particles in the case of colloid. So let us discuss colloids in detail. First one, phases of colloids. phases of colloid. There are two phases in a colloid. First one, dispersed phase, and the second one, dispersion medium. It is same as that of the solute and the solvent in a true solution. Dispersed phase is similar to the solute in a true solution. That means dispersed phase means the phase which is present in smaller amount, and it is the substance which is dispersed in colloid. And it is the substance which is dispersed. And dispersion medium is same as that of the solvent in a true solution, and it is present in larger amount. Dispersed phase is dispersed in dispersion medium. That means the substance in which dispersion takes place is known as dispersion medium. The substance in which dispersion takes place. Next one is classification of colloids. Different types of classifications are there based on the criteria we are taking. First of all, I am going to write the criteria used to classify the colloids. The first one is based on the state of phases. That is state of dispersed phase and dispersion medium. And the second criteria is based on the nature of the dispersion medium. Nature of dispersion medium. Third criteria is based on the interaction of phases. Fourth one, based on the charge of colloidal particles. And the fifth one is based on molecular size. So first one is based on the states of phases. Phases are dispersion medium and dispersed phase. Dispersion medium and dispersed phase. If the dispersion medium is solid, there are three possibilities. Dispersed phase can also be a solid, or it can be a liquid or gas. So, if the dispersion medium and the dispersed phase are solid, then it is called a solid salt. If dispersion medium is solid and the dispersed phase is liquid, then it is salt. Just salt. If dispersed phase is gas, then is aerosol. From this, we can conclude that if the medium is solid, then it is a salt. If it is dispersed phase is solid, then it is solid salt. Liquid means just salt. If gas, then it is aerosol. Then, next one, the dispersion medium can be a liquid. Three possibilities are there. It can be solid, liquid or gas. If it is solid, then gel, liquid, then it is emulsion. And third one, if gas, solid, if dispersed phase is gas, then it is aerosol. Actually, if dispersed phase is gas, then it is commonly known as aerosol. Whether it is in solid medium or in liquid medium, it is aerosol. Okay, the third one is gas. So, here also solid, liquid, gas. Here, gas dispersed in another gas is not a colloid because both are gas, and if they mix each other, they will form a true solution. So, it is not, it is a true solution. So, it cannot be classified under colloid. It is true solution. So, only two are there. First one is gas, solid in gas and liquid in gas. And solid in gas is known as solid form. Solid form. And liquid in gas is form. Just here I am sharing examples of these 8 examples coming under these 8 classifications here. Just have a look. Then, based on the nature of dispersion medium, it is classified as hydrosol, alcohol, benzosol, and aerosol. The word hydro denotes water. That is, if the dispersion medium is water, then it is hydrosol. If dispersion medium is alcohol, then alcohol. If it is benzene, then benzosol. If it is air, then aerosol. Then next classification, based on the interaction. Based on the interaction of phases. Based on the interaction of phases, colloids are mainly classified into 2. The first one is lyophilic and the next one lyophobic. Lyo means liquid and philic means loving. So, lyophilic in the sense, if the dispersed phase have greater affinity towards the medium, towards the dispersion medium. The dispersed phase have greater affinity towards the dispersion medium, then it is called lyophilic. While lyophobic colloids are liquid hydride. That means the dispersed phase have no affinity towards the medium. Dispersion medium. Let us differentiate between lyophilic and lyophobic colloids. First of all, lyophilic colloid mean solvent loving, and lyophobic is solvent hatred. Since the lyophilic is solvent loving, it is self-stabilized. It is self-stabilized. But in the case of lyophobic, it is solvent hatred. So we require an additional stabilizer to stabilize lyophobic colloids. So require stabilizer. Lyophilic colloids are usually reversible in nature, and we can prepare this by easy methods, and we can readily prepare lyophilic colloids by simple mixing. While in the case of lyophobic, these are irreversible in nature and can formed only by using some special methods. Special methods are required to prepare lyophobic colloids. For preparing lyophilic colloids, we need large amount of solvent. Large amount of solvent is required to prepare lyophilic colloids, while lyophobic colloids, for the preparation of lyophobic colloids, we need only small amount of solvent or small amount of electrolyte. Here also we can write electrolyte instead of solvent because the word solvent is not used in the case of colloids. And the surface tension of lyophilic colloids are much lesser than that of the original dispersion medium. But if we compare the surface tension of lyophobic colloids and the medium, it is almost same. Okay, it is almost same. If we use water as dispersion medium, then it is called hydrophilic. Because hydro is the word used to represent water. So if it is water loving, then it is hydrophilic. While in the case of lyophobic, it is hydrophobic. Now we can write some examples also. Lyophobic colloids: gel, starch, gelatin. Some examples of lyophilic colloids. While lyophobic colloids are gold sol, ferric hydroxide salt, FeOH thrice salt, ferric hydroxide salt, arsenic sulfide salt, that is As2S3 salt. These are okay. This is all about lyophilic and lyophobic. Then, based on the charge of colloid, based on the charge of particles in a colloid, you can say that positive and negative colloids will be there. Positive colloids and negative colloids. Ferric hydroxide salt is a positive colloid and arsenic sulfide salt is a negative colloid. Positive colloid means the charge of the particle is positive and negative colloid means charge of the particle is negative. That's all. Then the last one is based on the particle size. Based on size. Based on size, colloids are classified into 3. 1. Multimolecular. Second one, macromolecular. And the third one is associated colloids. Multimolecular colloids means actually the particle size are very less. That is, it is not coming to the dimension of colloids. That is, the particle size is actually less than 1 nanometer. But in certain cases, these particles held together by some weak van der Waals forces of attraction and aggregates to form colloidal dimension. Now, the aggregate formed here is coming under colloidal dimension, that is greater than 1 nanometer. This is greater than 1 nanometer. Gold salt, sulfur are multimolecular colloids. Then, coming to macromolecular colloids, its actual size is coming under colloidal dimension. Initially onwards, the particle size is greater than 1 nanometer. Examples are the polymers such as starch, proteins, cellulose, etc. are examples of macromolecular colloids. Then, associated colloids. Associated colloids means at low concentration, their particle dimension is not coming under colloidal dimension. Their particle size is not coming under colloidal dimension. But when concentration increases, they aggregate to form colloids and are called associated colloids. The surface active compounds like soap, detergents, etc. are some examples coming under associated colloid category. And this associated structure is known as micelle. Here we are not going to the details of micelle formation, that will be discussed later. Okay, this is all about the classification of colloids.